Is coming to the next topic, heating effect of electric current. Before that, I will show you some pictures which are related to electromagnetism or electric effect. Here I am showing you and demonstration about the magnetic effect of electric current activity about to demonstrate the magnetic effect of electric current. So materials are not available and unable to perform this activity. That's why just I am giving you a simple idea about this magnetic effect of current. Magnetic effect of current. So let's see just. Okay, then see how these electromagnets are showing the effect, right? Coil connected to a cell, magnetic needles are placed. See the deflection in the diagram, both sides. Then also see how strong. Then electromagnets polarity, identifying the poles. Then also see the aurora effect or northern or southern lights, the natural phenomena, one of the beautiful phenomena, right? This is, see, aurora. Now let us discuss the heating effect of electric current. Before that, let us know the new term which is maybe you not listen or maybe you not learn in class 7th. Class 7th. Why? Because a new word to you, resistance. Resistance in the sense in biology you can call as immunity power or resistance power must have in our body. So we know that what is that use of resistance power. That resistance power makes us strong. Resistance power make us do not fall in ill, not get any disease or cannot fall in ill. So some white blood cells are present in our body. They act as a resistance power. They give resistance power to us. So we are healthy, right? Similarly, before understanding the heating effect of electric current, let us know what is meant by the resistance. We know some of the materials are good conductors of electricity, which are allow the electric current to pass through them. Those materials are allow the electric current to pass through them, we can call as good conductors. Those did not allow the electric current, we can call as the insulators or the poor conductors. Right? That ability allowing current less or more, simply we can call as resistance. Some of the people easily fall in ill, right? That means easily get some diseases. Some are did not get. Sometimes some people get very rare cases. So those people, those persons having more can say resistance power in their body, they won't fall in ill. They won't get any diseases. Not now, right? Okay. let's see resistance. All the materials oppose the flow of current through them. All the materials oppose the flow of current through them. Some are less and some are more. Some materials has the ability to oppose the flow of electric current through them less. Some of the materials have more ability to oppose, to stop the flow of electric current. That ability or the degree to which a material opposes the flow of current through itself called resistance. We will learn more about this resistance in class 10. On which factors the resistance depends, nature of the material, temperature, area of cross section, length of the conductor or length of the wire. We will learn some more information in class 10, right? Then, so through means the ability or the degree to which a material opposes the flow of current through itself called resistance. A wire, a copper wire has its resistance even though it is a good conductor of electricity. A silver wire also has a resistance to oppose the flow of electric current. These also have resistance, but they have less. But some of the metallic wires, some of the conducting wires, even they are the conducting current, even they are the good conductors, but they have more resistance. They have more resistance to oppose the flow of electric current. So, when an electric current is passed through a high resistance wire, like nichrome is a metallic wire. Nichrome is a metallic wire. So, for example, it has a high resistance wire, a nichrome material or a nichrome wire or nichrome metallic wire has more power, more ability to oppose the flow of current. So, when the electric current is passed through a high resistance wire like nichrome wire, the resistant wire becomes hot and produces heat. Such effect of electric current is called heating effect of electric current. So, magnetic effect of electric current means if a current is passed through metallic wire, what happened? Magnetism generated. If the electric current is passed through a high resistance wire, heating, it produces heat. So that is called heating effect. Right. So this is heating effect of electric current. That means electrical energy is converted into heat energy. Electrical energy converted into different forms: light energy, mechanical energy, fans are rotating, then light energy, bulbs are giving light, right? Magnetic effect also is given. Then electrical energy is converted into heat energy. That means this heat energy heats up the resistance wire. We can understand by doing some activity, simple thing, right? We are using electric iron in our home for ironing our clothes, right? So in that we have to use nichrome wire, nichrome sheet high resistance wire opposes the more current, opposes the flow of current through that. That's why what will happen, that nichrome sheet and nichrome element, we can call it as nichrome element. Simply we can call it the element. Later we will discuss about it. So when current is passed through that nichrome wire become hot because of electrical energy is converted into electrical energy. Electric energy is converted into heat energy. Electric energy is converted into heat energy. Due to that heat energy, that nichrome wire become hard and produce heat. Induction stoves also, right? So this amount of heat produced in a wire during heating effect of electric current depends on the heating effect of electric current is depends on resistance. Depends on the resistance. If the metallic wire or the material or the metal wire the substance used in particular appliance, right, resistance of a wire, that depends. And also material, what resistance of a wire, what material you have to use to make that high resistance wire. Material of a wire, what material you have to use, then amount of current, amount of current passed through the coil or passed through the resistance wire. Passed through the resistance wire. So these three factors are influences or affected the heating effect of electric current. How much heat energy should be liberated during by passing electric current to a high resistance metallic wire depends on the resistance of a wire. The wire has more resistance or less resistance. Less resistance, less heating effect, more heating, more resistance, more heating effects. That what type of material it is used? It is copper, silver, aluminum, iron, or nichrome, or any alloys, right? Then amount of electric current, how much electrical energy, how much electric current is passed through that particular resistance. These three factors are affect the heating effect of electric current, or the heating effect of electric current is depends on the heating effect of electric current is depends on these three factors, right? Greater the resistance of a wire, the greater will be heat is produced by a given current. For example, copper has low resistance. When through this low resistance copper wire, if electric current is passed, less heating effect is occurs. Similarly, if you use other than copper, if you use nichrome is alloy. Nichrome maybe nickel and chromium, right? Nickel and chromium mixture. What will happen? It has more resistance power to oppose the passing electric current. So we should be pass more current to produce heat energy. Due to high resistance of nichrome wire, more electrical energy is converted into heat energy. So a huge amount of heat energy is produced. So greater the magnitude of current passes through a given wire, resistance of wire, more resistance, more heating effect. Less resistance, less heat effect will be found. And material, it is a single metallic wire like copper, or alloy like nichrome. Nichrome, it is nickel plus then amount of current passed through it, how much electric current is passed through it. More electric current is passed through a metallic wire, more heat energy is produced. That means a small current passing a wire produces less heat, but a large current passing through a same wire produces much more heat. For example, if we consider the copper has less resistance, generally it produces less heat. If we pass more current to the copper wire, more heat energy is produced. More heat energy is produced. For example, when normal amount of current passes through the copper wire in a household electric wiring, the wires do not become much hotter, but the large current flows accidentally, then the wire becomes extremely hot, may cause a short circuit, causes some what you can electric fire accidents. So this is about heating effect of electric current. Then next class session or the next time we will discuss applications of heating effect in our daily life. What are the applications we have? Electric heating appliances like electric iron, electric heater, electric bulb and electric fuse. After that we have voltaic cell, dry cell, rechargeable batteries. We will discuss some story behind the cells, how was the cell made. So the remaining any other important applications, any other important topics also we will discuss in the next session. Right? Thank you so much. So keep touch with my YouTube channel, Haripriya's videos. Signing off. Thank you.